answer in the equation. Solve the equation. It doesn't ask you to do that, but I added that because these are all equations that you can solve now. If you choose the correct letter, solve the equation that you pick. Solve the equation that you choose. I should not have to come and tell you individually. Get started. And you shouldn't have to do that. You should be able to box in a basic fact since it is a multiple of 10 and solve it that way. Brayden, you cannot sit there with nothing on your paper. You need to have something. It is a multiple choice question. Look at this, okay? It says, Patrick has a stamp collection. He has stamps from 9 different countries. He has 175 stamps for each different country. Which expression would give the best estimate of how many stamps he has? Okay, expression is another word for equation, okay, or another word for which number sentence. So there's all kinds of different ways, but expression is just a word, another word for which equation would give you the best estimate, okay, of the number of stamps that he has. The question didn't actually ask you to solve, okay, but because I knew you could solve all of those expressions, I asked you to take it a step further and go ahead and solve that expression or equation for me. So first of all, who can tell me, based on the problem, which equation would we use if we were going to estimate the number of stamps that Patrick has? Park, which equation or which expression did you choose? Okay, and Park, how did you know that B, 9 times 200, was the correct answer? Okay, good. You have to take the larger factor. Okay, 175. It asked for an estimate, so you knew you were rounding. Okay, 175 rounds to 200, so 9 times 200 is the correct answer. Okay, so B was the answer to the question. Okay, now if you chose B, who can tell me what 9 times 200 is? Ray, what is 9 times 200? Okay, 1,800, so we know that Patrick has about 1,800 stamps in his collection. Okay, all right, go ahead and close your blue Go Math folder, or math folder. Okay, I hope you can see what I'm doing. Leave your Go Math book closed for right now. Before we get started with the lesson today, we're going to be looking at multiplying using the distributive property today. Okay, so we're kind of done right now with estimating, okay, with tens, hundreds, and thousands. We're pretty good at that. Today we're actually going to start multiplying numbers like 18 times 6, okay, and getting the actual answer instead of rounding 18 to 20 and getting an answer. Okay, so today is where we really start multiplying those 1-digit numbers by 2-digit numbers, 3-digit numbers, 4-digit numbers. Okay, you are going to learn tons of strategies to help you do that. And at the end, okay, at the end of chapter 2, you have to pick the strategy that works best for you. Okay, so you're gonna learn a lot of ways to do this. You have to find the one that works for you every single time. Okay, but before we get started this morning, because there's about to be a question that Fred the Fox shows you about this, does anybody know what a parking meter is? Does anybody, if you don't, it's okay, you may have never seen a parking meter, but some of you have, okay? So, Braden, can you tell us, what is a parking meter?
A parking meter is something when you park, it has time
Okay.
It has a time limit.
Okay.
If that time limit runs out and you don't leave by that time, you can get a ticket.
Okay, but do you know how you get the time on the parking meter?
You have to put money in.
Okay, that's the important thing. Okay, sometimes when you go to a big city, okay, I've never seen one in Oxford, okay, or Anniston for that matter, but if you go to a big city like Birmingham or Atlanta, okay, and you need to park in downtown Birmingham, okay, a lot of times you have to pay to do that because there's lots of people that want to park there and there's not enough parking for everybody, and so you have to pay to park. Okay, well, big cities have set up what's called parking meters so that they don't have to have a person out there to take up money. Okay, and Braden's right. You put money into this little machine and it gives you a time limit. Okay, let's say sometimes maybe you'll put a quarter in. And for a quarter, you can park there for 10 minutes. Okay, once that 10 minutes is over, if you don't put another quarter, okay, he's right, you can get a ticket because your time ran out. Okay, and so that's how a parking meter works. And Fred the Fox is going to kind of show you a parking meter. So I wanted to make sure you understood that before he just started talking about something that you had no idea what it was. Okay, all right, because the numbers don't match, you are simply watching. Okay, I will tell you when it's time to go into your book. By the time we get to your book, your snack needs to be completely eaten. So make sure you're watching and eating your snack at the same time. All right, here we go.
How can you use the distributive property to multiply a two-digit number by a one-digit number?
No estimating today. Just 2 digits by 1 digits, and we're getting actual products today.
Hello, and welcome back to the diner. It's busy here as always. People are coming and going non-stop. Oh, here comes another person now. Hey, you know that parked car belongs to one of my neighbors? He comes here 4 nights each week. I wonder how long he's been parked for tonight. Let's see how long his car's been parked. Click the parking meter to find out.
Okay, so there's an example of what a parking meter might look like. They don't all look like that, but they're similar. Okay, so this person comes to this diner and they park there 4 nights each week. Okay, let's see what the parking meter tells us.
As usual, 19 minutes. Just enough time to eat a quick meal. You know, I think we can figure out how much time my neighbor spends here each week by multiplying.
Okay, so we want to know a total for the week. Okay, 19 minutes each night.
I have an idea
4 nights
about
a week.
one way we can multiply these two numbers. Let's use the distributive property to see how to multiply a 2-digit number by a 1-digit number. Ready? Okay, let me show you how to do that.
Okay, so we're not looking for an estimate today. He wants to know exactly how much time does his friend spend parked there, okay? And so we are looking for the actual answer, 4 times 19, okay? That's not a fact that you should know just like that. You're only supposed to know through your 12s, okay? And so you're about to see how we can multiply this number using the strategy, the distributive property. Okay, and it may not be, usually it's not this same problem, okay, so it's probably going to be another problem using the distributive property. You need to watch carefully because you're about to have to do this on your own, okay? All right, here we go. Let's listen.
You can use the distributive property to break apart numbers to make them easier to multiply. Let's use the distributive property to find 4 times 14. You can outline a rectangle on a grid to model the multiplication. Now think of 14 as 9 plus 5. Break apart the model to show the problem.
Okay. Whew. They just talk really, really fast. Okay, but the problem that we're trying to solve, it's not 4 times 19, and I didn't think it was. We're actually going to use the distributive property to solve 4 times 14. Okay, and the distributive property just says I can take my bigger factor. Okay, it's always the bigger factor, and I can break it down into smaller numbers that I do know how to multiply. Okay, if I'm where I'm supposed to be as a 4th grade math student, I know how to multiply by 9s. I know how to multiply by 5s. Those are facts that I know. I don't know 14s. Okay, I'm 33 years old, and I don't know my 14 facts. Okay, just right off the top of my head. So the distributive property says I can take this bigger number, I can break it down into smaller numbers. 9 plus 5 is still 14. It will make it easier for me to multiply. Okay, so today you're going to learn 2 different ways, but the first way you're going to learn is you're going to learn by drawing it on a piece of grid paper. Okay, this is a 4 by 14. Now watch how they break this 14 down into 9 groups and 5 groups to make it easier to multiply. Okay? Alright. Ooh, they went really fast on that.
The model now shows 4 times the sum of 9 and 5. Use the distributive property. What does each smaller rectangle represent?
Okay, so now instead of having that big number 14, now we've got a 4 by 9, which means 4 times 9, okay, which you should know, okay? Who can tell me what 4 times 9 is? Just like that. Okay, if your hand's up, what's 4 times 9?
36.
Okay, so see, you did that quickly. But if I had asked you to raise your hand and tell me 4 times 14, most of you wouldn't have been able to do that. I wouldn't have been able to do that. Okay, then you got a 4 by 5, which means 4 times 5. Well, what is 4 times 5? 20. So I've got 36 boxes here, 20 boxes here. All I have to do is put my 2 numbers together, and I've got 4 times 14. Okay, and pretty soon it's going to go really fast for you. So that's what they're talking about. But watch how they finish the problem.
4 times 9 is 36, and 4 times 5 is 20. You found the product each smaller rectangle represents. Now find the sum of the products.
So now we have to put the 2 products together. Okay, 36 plus 20, okay, gives
The sum of the products is
56.
56. The distributive property states that when you multiply a sum of 2 numbers by another number, it is the same as multiplying each addend by the number, and then adding the products. So, you know that 4 times 14 is 56.
Okay, so the reason that works, okay, is because the distributive property says I can take 14 and I can break it down into okay, smaller numbers that I know I can multiply, and then at the end I add my products back together. Okay, because to distribute means to take a big group of something and make smaller groups out of it. Okay, that's what the distributive property of multiplication does. Alright, let's see one more example.
You can use base 10 blocks to model a problem. Let's use base 10 blocks to model 4 times 14. The base 10 blocks break apart the 10s and 1s of the greater factor. So you can think of 14 as 10 plus 4 and use the distributive property to find the product. 4 times 110 is 4 times 10. How many does that equal?
What is 4 times 10?
40.
40. Okay.
40. Now multiply 4 times the 1s. There are 4 1s. What is 4 times 4?
Okay.
16. Each part of the model shows a partial product. Add the partial products, 40 and 16, to find the product.